Good morning, class. We're going to be discussing geometry, 2 and 3-dimensional figures. So we'll be going over the slides. I'll read through them with you. There's 33 slides, so we'll break the video up into multiple parts. But let's begin. Hopefully this works. Okay, well, you get to experience the technical difficulties with that. Okay, so geometry. We're going to be talking about polygons, and the key is polygons are closed figures whose sides are all segments. Each side of the polygon intersects exactly two other sides, but only at their endpoints. Okay, so you see that there are lines intersecting, but only at the endpoints. So the examples on the left would be key examples right here. This is a 3-sided figure, 4-sided figure, and 6-sided figure. Now this is not one because it is not closed. This is not one because this is not line segments. These are curves. And this is also not one because these line segments are intersecting at multiple points. Okay? And they intersect each other. Okay? So we'll move on. Concave versus convex. So concave implies that lines are going to pass through also the interior. So if you look at the line, if you made a line from endpoint to endpoint, it'll also pass through the interior. So this is still a polygon, but it's a polygon that is concave. Notice the angles that you're going to see. Convex is going to be no points of the line. So if you take a line and you just draw it straight, like from endpoint to endpoint, and keep going, this one's going to go through, this one is not. So notice these ones all continue on the outside. They only pass through a line and continue on. Okay, classify these. So this one, would this be convex or concave? Now if we drew a line and it goes straight, this one wouldn't hit any. This one wouldn't hit any. This one would pass through our figure. So if we draw a line straight down this one, it passes through our figure. Okay? Same thing with this. So this is concave. This one clearly is going to be convex. Okay? And this one's going to clearly be concave. Okay? A regular polygon is a convex polygon whose sides and angles are all congruent. Good definition to remember. So first definition we needed to remember was polygons are closed figures whose sides are all segments. Each side of the polygon intersects exactly two other sides, but only at their endpoints. So you should write that down. And concave, convex are useful. Some useful definitions. And finally, a regular polygon. Okay? Regular polygon is a convex polygon whose sides and angles are all congruent. So the angles are all congruent, and the sides are all congruent. Okay? So classify them. Are they regular or irregular? There should only be one regular one based on all of these. Alright, so notice this one. Are all the sides the same length? No. And it's also concave. Are all the sides congruent? Yes. Are all the angles congruent? Yep. So that is irregular. All the sides congruent? Yep. Are all the angles congruent? Yes. Is it convex or concave? Concave. So this one's not a regular polygon. Okay, let's name them. 3 sides is triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. Now, when we get to 11, actually, we're going to repeat. And this is in Greek, we're going to go from 1 plus 10. So, hendecagon. Notice hendecagon is actually hen 1, decagon 10. So 12 would be dodecathon. And actually, with n after 12, well, technically after 5, we will always have n gone. So n gone. Okay. So there's the 3 side is three side is triangle. 4 side is quadrilateral. Quad meaning 4, lateral meaning sides. 4-sided figure. Okay. Okay. Name each polygon, then classify as convex, concave, regular, or irregular. My apologies for the yawning. Okay, first one. How many sides? 6-sided, concave, and it's irregular. Okay. Second is a 9-sided, so it's a nonagon. So first one was a hexagon, second one was a nonagon, and it was convex, and it is regular. Okay, the third one is a quadrilateral, and it is convex, and it is irregular. Okay. Here's perimeter and area formulas. Write them down. Perimeter one's pretty straightforward. Triangle, add all the sides. Square, add all the sides. Rectangle, add all the sides. Circle, 2 pi r. Area. Area of triangle is 1/2 base times height. Area of square is the side squared. Area of a rectangle is length times width. Area of a circle is pi r squared. Write these down, so know these. Perimeter means distance around. Circumference is the perimeter of a circle. Okay, I'll give you a second. Write these down. Okay, find the perimeter / circumference of each figure. So the first one is a rectangle. So we are actually going to, for this one, we are going to multiply each side by 2. So we'll get 8 plus 34, and then we'll just add those two together. So 8 plus 34 is 42 feet. So that's our perimeter. Our area is 4 times 17. 4 times 17 is 68. 68 feet squared. Okay, the perimeter of a circle is 2 pi r. 2 times pi is still 2 pi. 2 times 7 is 14. So our perimeter is 14 pi miles. And then you can round to the nearest tenth. So if you round to the nearest tenth, you're going to get, my apologies, I actually have to plug this into a calculator. So let's get 14 times pi, and you should get 43, so it's actually 44 miles. And then to get the area, you do 7 squared, so 49 times pi. And you should get 153.9 miles squared. Okay, the triangle, the outside is 8.1 plus 8.1 plus 8. So 16.2 plus 8 is 24.12 millimeters. That's our perimeter. Our area is 7 times 8 times 1/2. So 56 times 1/2 is 28 millimeters squared. Okay? Find the perimeter and area of triangle with vertices. P is -1, 3. Q is -3, 1. -3, -1. And R is 4, -1. Okay. I'll give you a chance to do this before we'll start the next video where I will give you the answer. Thank you guys so much. We'll continue on with the next video.